In this video, we're going to be looking at acid plus metal reactions, and this is actually not an acid-base reaction, it's a redox reaction. Acid plus a reactive metal will give salt plus hydrogen gas. So in this particular case, that bubbles here are of hydrogen gas. Now hydrogen gas is colourless and odourless. It's also flammable and in certain situations can be explosive. In the laboratory, hydrogen gas can be made by reacting magnesium ribbon with acid and having a test tube over the top, and this allows you to collect hydrogen gas by the downward displacement of air. To test for hydrogen gas, we do the pop test, and the pop test we use a lighted splint and we ignite the hydrogen gas, which will form water vapour. The biggest ever example of this was the Hindenburg tragedy. Not all metals or acids will react in this fashion. So some unreactive metals are copper, silver, gold and platinum, and also mercury. Of these, the copper, silver, gold and platinum are all metals that we like to wear in our jewellery. And we like to wear them in jewellery because they are unreactive. Not all acids react in this matter. Nitric acid never reacts to form hydrogen gas. It always forms nitrogen oxide gas or nitrogen dioxide gas, depending on the concentration of the gas. And concentrated sulfuric acid won't produce hydrogen gas, it will produce sulfur dioxide gas. So when we're doing these types of reactions, we are looking at using reactive metals and dilute acids. So you can see here, this is showing a reactive metal, so both this and this one are reactive metals. And you can see that they are producing bubbles of hydrogen gas. But this being copper is an unreactive metal. And doesn't react. So acid plus reactive metal makes salt plus hydrogen. So let's go through an example. Hydrochloric acid plus magnesium will give us hydrogen gas, and the salt, well, the salt comes from the metal and the non-metal grouping here, so it's magnesium chloride. Let's write that as an equation. Hydrochloric, and it's an acid, so it'll be aqueous, plus magnesium. All metals apart from mercury are solids. Will give us magnesium chloride. You have to use your valence to be able to write the correct formula, plus hydrogen gas. You need to be able to work out the state symbols for magnesium chloride. So looking here, all chlorides are in the soluble in water state, so it must be aqueous, and hydrogen gas is a gas. Let's have a look at doing observations. All metals except copper and gold are silver, and magnesium chloride solution, checking your colours ions in aqueous solution table, is a colourless solution. So observations: colourless solution, silver metal, silver solid, colourless solution, and a colourless, odourless gas. So your observation would be a silver solid dissolves or disappears to give a colourless solution and bubbles of a colourless, odourless gas. Let's try a second example. Acid plus reactive metal gives salt plus hydrogen. So our acid is sulfuric and our metal is chromium, which is a reactive metal. Salt, leave till last, but hydrogen is easy. The salt must be chromium and the anion from the acid is sulfate, so chromium 3 sulfate. Now let's write an equation. Sulfuric acid, which must be in solution, plus chromium, which is a solid, gives us chromium 3 sulfate. Now you have to use valence to write the correct formula. Plus hydrogen gas. Now we need to balance this equation. Start with the metals. There are 2 chromiums on the product side, 1 on the reactant, so I'm going to put a 2 there. There are 3 sulfate groups, so I'm going to put a 3 in front of the sulfuric. There are 3 times 2 is 6 hydrogens in the reactants, so 3 2s are 6 hydrogen gas in the products. Now let's check the state symbols. Our next stage is to work out the state symbols. Hydrogen is a gas, chromium sulfate, so most sulfates are soluble, and chromium is an exception, so we write aqueous. Now we have to work out the colours. Now chromium is a metal, so it's silver, and chromium sulfate, which is aqueous. Let's check our solubility tables and our coloured ions in solution table, and you can see that chromium here is a deep green solution. So our overall observation would be a colourless solution, a silver solid, a deep green solution, and a colourless, odourless gas. So our observation would be a silver solid dissolves or disappears to give a deep green solution